While I complete my chores, I'm going to teach you some basics of data analytics, because a lot of you don't know what they are, and these are things that you're always supposed to remember until the day you die, and they're not very complicated. I know because I've worked 3 years in an office and I've seen some colleagues that have no idea. You may be someone that is trying to branch out into data analytics, and you read a bunch of textbooks that begin with, let's say, the history of statistics or the history of data analytics. These are things that are fun to know, I guess, for some nerds, but then it's not necessary that you know 1700s में statistics में क्या हुआ था, 1800s में क्या हुआ था, and whatnot. So there will be no selling anything to you. So I'm just doing this out of the goodness of my heart while I do some chores around the house. So if that distracts you, I guess cope with it. Anyways, without further ado, let's get into it. So, what is data? Data is a collection of facts and statistics that are collected to tell a story or to come up with an inference or to solve a problem. Now, intuitively, let's not think of a table of an Excel table or like a rectangular data frame. Let's see what data can be. I've let my tap loose right now, so the amount of water coming out of it, the speed at which wind blows, the amount of pixels in the image that you have, the intensity of those pixels, which is a lux value. These are all forms of data. How many TVs have I sold? Of those TVs, what categories were they? Were they LCD, plasma, LED, OLED? All of these is a form of data, or all of these are different data sets or different data points. Take a minute to identify how data is around you. There's a chance that every single object can be quantified or can be presented in the form of a data frame around you. So I encourage you to do that, because this will expand your horizons as to what data actually is. If somebody asks you, why are you doing this job? Data is seemingly everywhere. If you're a mechanical engineer, you are doing data analysis to come to an inference ultimately. So it's not restricted to one particular profession, even commerce folks. I guess everybody, apart from arts, I mean, even in arts, there's a lot of data analysis involved. But anybody that's doing some form of calculation, some form of pictorial representation, they are doing or they are using data analysis. So that's not a big deal. Now, what are the taxonomy of data types, or what are the different types of variables? Broadly, any statistical data can be classified into numerical and categorical variables. Within the numerical variables, we have discrete numerical variables and continuous numerical variables. What are discrete numerical variables? Definition wise, these are things that can be counted, and these are things that take integer values. Basically, anything that you can count is a discrete variable. This also includes the number of hair on your head. This also includes the number of stars in the galaxy. When I say can count, I don't mean it as a skill or a capability issue, but it makes sense for you to count it. Now, I can't count weight, I have to measure the weight, right? So, these measures or the quantities that can be measured are called continuous numerical variables. If it is not clear, the intuition is behind how I use or how I quantify these measures. Counting, discrete; measuring, continuous. Why are they called continuous? Because of the fact that these are enums, these can be enums, these can be floats for our CS engineers here. But basically, these can take up decimal values. I can say that 9.008765 liters of water was used to wash these vessels. I can't count that much. I have to measure the amount based on the precision or the accuracy of my measuring scale. I can increase it to as many decimals as I want. So, things that can be measured are continuous numerical variables. Now, there are different scales of measuring numerical variables. There are intervals like temperature, where a true zero does not exist, and there are ratios where a true zero exists. Now, when I say a ratio, I know you're thinking of a fraction with a numerator and a denominator. That is fine, but a fraction is a fraction. Now, when I say something is 10 kgs, I'm taking the multiplicative unit of 1. So, if 1 is the multiplicative identity, I'm saying that something that is 10 kgs is 10 times heavier than something that is 1 kg. That is what the ratio means here. So a true zero exists in ratios because I can say that this packet has 0 kgs. That essentially means it has nothing inside. But when I say that the temperature is 0 degrees, it doesn't mean that there is no temperature in the room altogether. इधर का तापमान ही नहीं है, ऐसा कुछ नहीं होता. यहाँ का तापमान है और वो तापमान 0 degrees है. Your temperature can be in the negative as well. It can be -1, -2, because it is a man-made thing. So is weight and everything. But a true zero exists in the weight because it makes sense for me to say that there is no weight. But it doesn't make sense for me to say there is no temperature because there is always some temperature, right? So that intuitively should help you understand the true zero concept. Basically, ratios have true zeros, intervals do not have true zeros. Moving forward, now our next sort of variables are categorical variables. Within the categorical variables, we have ordinal, nominal, and binary data types. Now, what is category? Categorical variables are variables that have a shared quality that can be very specifically categorized into different buckets or different bins. Anything, let's take one of our previous examples. If I say that my TV is LED, if I say that my TV is plasma, I'm categorizing it. Similarly, I am an Indian. I am categorizing myself into a country. It is a fact. I am an Indian. You live in this zip code. You are categorizing yourself into that zip code. 100 marbles of the red color were sold. These are categorized into the red category, the color, the nationality, pin code. All of these are categorical variables. Intuitively, I think you should realize why categorization is important. Firstly, it is very important to do this because your software that you'll be using, it's either going to be a programming language like R or Python, or it's going to be some hefty thing like Azure. But basically, your software uses the categories or the type of variable to either predict your dependent variable, or it uses it to assign a certain predefined value. What I mean by this is, let's say, sort your marks by the descending order, and the first highest should be the first rank. So I'm assigning a rule to my algorithm, right? So this rule assigning can be done through my categories. My first rank is a category. And when there is a ranking or a hierarchy within the categorical variable, that is called an ordinal variable. Nominal implies that there is a nominal comes from the word name, so it is categorized on the basis of the name. Ordinal from the cardinality or the ordinality, that is the rank or hierarchy or relationship. But basically, nominal is categorized on the basis of the name. Now, there can be some complications here as well. Now, my coordinates, let's say there are 10 houses in a lane, and all of these 10 fall in under a pin code. Now, the coordinates of these 10 houses, they are numerical variables because you measure the coordinates. The distance between these coordinates can be calculated. The distance can be subtracted. An average of the distance makes sense. Calculating a mean, aggregating it in a certain way, makes sense. So this is a continuous numerical variable. But I am categorizing all of these numerical variables, that is all of these coordinates, into one zip code. So I am taking a whole bunch of data points and categorizing it into a one nominal variable. So intuitively, you must understand this happens quite a lot. If I were to take some fantastical examples, going back to the pixels thing, firstly, just based on the intensity of light, your pixels can be categorized into different colors: red, light red, no intensity, black. So intuitively, you may understand that your how your pixels or how we perceive color is by categorizing a numerical variable, that is by categorizing a wavelength and an intensity of light into a color. And then this is used in various fields of medicine where artificial intelligence is now used to identify scarred tissue. It has a different pattern of intensities. Or when your CNN models use these intensities to identify whether this picture has a dog or a cat, your image detection, basically what it does is it identifies these numerical values of pixel intensities. It finds a pattern of those pixel intensities, and when it finds a pattern, it detects, is this an umbrella in the image, is this a cat, is it a person, is it, I don't know, Deepika Padukone. So that way your numerical variables, a pattern can be detected within your numerical variables and they can be categorized into a categorical variable. So intuitively, I hope you have understood what this intuitively, I hope you've understood the taxonomy of these variables or different data types and why it is important to have different data types. Why it is important? Basically, your model will assign a particular algorithm based on the type of variables. X-axis में क्या होगा? What is going to be on your x-axis? If it's a categorical variable, I can say red, white, and blue. And let's say there are 10 red toys, 50 blue toys, and 100 white toys. So I can have a bar graph with those values, and it makes sense because we have categorized, or we have actively chosen to put the uh, categorical variable on our axis. Essentially, it matters a lot for the modeling, it matters a lot for the visualization, and it matters a lot to set some predefined rules. What rank, what light ranges are going to be termed as red, what light ranges are X-rays, what light ranges are gamma rays. These predefined rules can be hard coded or conveyed to your program or your algorithm through the existence of categorical variables. In the next class, we will be taking a look at the estimates of location, that is your central tendency, mean, median, mode, and after that we'll take a look at the estimates of variability, standard deviation, all that. Hope you've had fun. Hope these things are clear to you. Do not get confused. If you have any doubts, ask. Do not yell at me. I do not pay attention to anybody on the internet. And like I said, I will be doing the chores while I complete this, so I'm that unserious about it. Hope you